Hello everyone. Let's take a look at this example on Bayes' theorem, and we're going to read the problem together, and I'm going to ask you to pause the video and work on it. This problem needs maybe a little innovation, and you need to give it more time. So I will recommend you give it full 15 to 30 minutes time and try your best. So this one says a cab was involved in a hit-and-run accident at night. And two cab companies, the green and the blue, operate in the city. 80% of the cabs in the city are green and 15% are blue. A witness identified the cab as blue, the cab that was in the accident. The court tested the reliability of the witness under the same circumstances that existed at the night of the accident and concluded that the witness correctly identified each one of the two colors 80% of the time and failed 20% of the time. What is the probability that the cab involved in the accident was blue rather than green, knowing that this witness identified it as blue? So you might need to read this a couple more times and write down the given information. And what I recommend here is you start with these given numbers and try to write them as probability notations, right? So just to give you a head start, 85% of the cabs are green. That means that's probability of green, right? So green, being a green cab, is an event in the sample space. So go ahead with that, and the good thing is you know already that this is an application of Bayes' theorem. So try your best and then come back to the video again. So let's continue. 15% of the cabs are blue, so let's call that probability of blue. And then it says the court tested the witness, and they figured that he or she correctly identified each one of the two colors 80% of the time and failed 20% of the time. So when the witness correctly identifies the color, what are the scenarios that he identifies the color correctly? Well, when he identifies a color as blue, when the cab was actually blue, that's a correct identification. There's another scenario of correct identification, and that is identifying the cab as green when it was actually green. So these two scenarios, their probability is 80%. So, and you can write them in terms of conditional probability, right? Probability of, and here I'm introducing a new event, witness identifies as blue, let's call it. Given that it was actually blue, that's a correct identification that they're talking about here. That's 0.8. And then another correct identification is when witness identifies it as green when it was green. That is also 80%. The same structure exists for the 20%, which is failure to correctly identifying. And failure to correctly identifying is when a witness identifies it as blue, but the color was actually green, and vice versa. Witness identifies it as green when the color was actually blue. So let's write those two down. So now we got our given information down in terms of probability notation. So now let's figure out what the problem is asking us. What is the probability that the cab involved in the accident was blue rather than green, knowing that this witness identified it as blue? First of all, knowing that, what comes after knowing that is the given part of the conditional probability. Witness identified it as blue is the given part. That is W blue. The probability that the cab involved in the accident was blue, that part is B. So we're looking for probability of B the cab was blue given that witness says it's blue. And that's what matters to the court. Now here is a great example of using Bayes' theorem, because now you already have the probability of WB given B, and you're looking for probability of B given WB, the opposite of that. So that's when it's best to use the Bayes' theorem. So we can say that is equal to probability of B given WB is equal to probability of WB given B times probability of B over probability of WB. But the thing is, we don't know the probability of WB. It's not given directly in the problem. But what we can do is we can calculate that using the total probability rule. And that's essentially what you see in the Bayes' theorem formula in the denominator. Here is the total probability rule at the bottom. Probability of, in our case, WB. So the top stays the same. But using the total probability rule means probability of WB given B times probability of B plus probability of WB given G times probability of G. And now you have all the pieces here. You need to replace them with the numbers that you got here. And when you do the math here, that is equal to 0.41. So it's 41% chance that the cab is blue when the witness says it's blue. It's 41% chance. The complement of this is something that this problem is not asking for, but we know that the complement of this probability is probability of G given WB. Probability that the cab was actually green given that witness says blue, it's 1 minus 0.41, so that's 59% chance. That's just, this is the complement probability of this. These two needs to add up to 1.